Hey everybody, the purpose of this video is to walk us through a number of problems actually from Chapter 10, Section 9, numbers 2, 4, 6, 8, and 10. They're the ones that didn't have solutions in the first 10 in our two-parameter hypothesis test homework. So basically what they want you to do is they want you to match up the type of problem with the description of the problem. So we've got number 2, we're taste testing something on consumers. We're testing whether the percentage of children is greater than the percentage of adults that like the product they're talking about. So first key word is percentages. We know we're dealing with either percentages or averages in this class. So we know we're dealing with percentages. So we know it's either going to be E or F. Two proportions or a single proportion. Those are the only choices to this point. And since we've got a percentage of children and we're comparing them to a percentage of adults, that means we must have two separate proportions because we don't have any particular number to test against, which is great because that's kind of fictitious anyway. So that I'm calling that a two proportions problem. E. Cool. Number 4, a football league. Average number of touchdowns per game was 5. A study was done to determine if the average number has decreased. Okay, so it says it's 5. On average. So we know we got average here. So of averages we have A through F. So they're testing the average number of touchdowns. So that's 1. Is there any other average they're talking about? No, we're just trying to see if that's decreased. So since we're trying to see if that's decreased, average number, 1 average, it's either going to be a single mean or a matched pair. Well, there's nothing to match it with. We're not comparing the game at the beginning of the season to the game at the end of the season and see if the numbers of touchdowns have changed there. Just the average number has changed. That's a single mean. We're going to call that D. Let's see, 6. Have a look at 6. According to a YWCA Rape Crisis Center, 75% of rape victims know their attackers. A study is done to verify this. Okay, so it's a percentage, 75%. So we know it's either E or F, and I've forgotten what those are now. E is 2 and F is single proportions. So we have a percentage of victims that know their attackers. So that's got to be F, which is a single proportion. We're testing against 75% to see if it's still valid. Number 8. An increase in the use of drugs and alcohol among local high school students. Okay, so let's think about this. As compared to the national percentage. Okay, so a survey of 100 local youths and 100 national youth is conducted to see if the percentage of drug and alcohol use is higher locally than nationally. Okay, so we got a local percentage and we got a higher percent, and a national percentage. That sounds like 2 percentages to me. That's going to be the same as E up there, or the same as 2 up there. 2 different percentages. 2 separate, I know the sample sizes are the same, but that's irrelevant. And last but not least, number 10, University of Michigan researchers reported in the Journal of National Cancer Institute, quitting smoking is especially beneficial for those under age 49. The risk probability of dying of lung cancer was about the same as those who had never smoked. Okay, so it's not telling us that they did that we are going to do a test, it's telling us that we have done a test. So we're checking the probability or risk of a group that has never smoked versus a group that has smoked. That sounds like 2 probabilities again. So that's the same as back here in number 8 in part E. Okay, so that's the evens. I also made a mention of identifying the 2 that are kind of ludicrous for reasons we discussed in class many, many times. So I'm going to look real quick at the rest of them. If you look at number 1, it says a powder diet is tested on 49 people, and then if you look at the second sentence, the population standard deviations are 2 and 3 pounds respectively. False. You never know that. You don't know what the population standard deviations are. If you did know that, then you would know what the population averages are, and you wouldn't be doing a hypothesis test. The whole point of doing these tests is to test to see if averages have changed. If you know what the averages are, there's nothing to test. So, false. Number 1 is kind of ludicrous. And anywhere else that you see the standard deviation is blah. Oh, I see it already. Number 5. From years of research, it is known the population standard deviations are 1.5811 and 1 year. Okay? Again, false. You don't know that. Okay? Years of research. Okay, I'll give you that. I'll give you your years of research, and I'll give you your margins of error shrinking down to essentially 0. I'll give you that too. But what I will definitely not give you, I will definitely not allow you to believe that even with a margin of error down here at 0, I don't think a margin of error of 0 necessarily means that that thing is going to stay exactly as it is indefinitely. So, number 1 and number 5, false. False, kind of ludicrous. But anyway, I hope this helped you with numbers 2 through 10 even.